Here's an example of a tree diagram question, probability question. Tina has 2 bags of counters, A and B. There are 5 red counters and 3 blue counters in bag A, and 4 red counters and 5 blue counters in bag B. And she's going to take a counter at random from each bag. And the first thing we've been asked to do is draw a probability tree to represent the information. So there are 2 things happening. The first thing is she takes a counter from bag A. And when she takes a counter from bag A, there are 2 possibilities. So that first section of my tree diagram needs to have 2 branches, one for each possibility. The first possibility is that she takes a red counter, and the second possibility is that she takes a blue counter. Here I'm going to write my probabilities. Well, here the probability is getting red. There's 5 red and 3 blue, so the probability of her getting a red is 5/8, because there are 5 red out of 8, and therefore, even without looking, I know the probability of blue, because it's the only other option, must be 3/8, because they must add up to a whole. It's certain that she's going to get red or blue. So that is bag A. It's not absolutely crucial for me to put that bag A at the top, but it's going to make it much more clearer for me if I need to come back to it at any point. Okay, it's part A, isn't it? Okay, and then there's the second event. The second event is bag B. In bag B, again, there are 2 possibilities, and it doesn't matter if she gets red in the first one or blue in the first one. There are still 2 possibilities for bag B, and those 2 possibilities, again, whether or not she gets red or blue, those 2 possibilities are red and blue, because bag B has the same colour beads as bag A. Okay, and the probability of red, well, you can see on bag B she's got 4 red and 5 blue, so the probability of red is going to be 4 out of 9, and the probability of blue is going to be 5 out of 9. And it doesn't matter what happens, whether it's red on the first one or blue on the first one, they're independent. It's either way, there are 4 red and 5 blue in this question in bag B. And that's part A done perfectly. Part B says work out the probability that Tina takes 2 blue counters. Well, we've already done most of the work for part B, because we've drawn ourselves a really clear tree diagram. Now we need to look where on the tree diagram Tina takes 2 blue counters. Well, that means she's going to have to take blue from A and then blue from B. So the only part of the tree diagram I'm interested in is this combination of branches here. There's no other way she can get blue, blue. Her other options are red, 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 blue, blue, red. None of those involve her taking 2 blue. So that's the only one I need to worry about. Now when I go down the branches, and in probability, whenever I want 2 things both to happen, this thing to happen and this thing to happen, I take the probabilities 3/8 and 5/9, and I multiply them. If I want this and this, I have to multiply them together. Now I have got my Casio scientific calculator, but I've left that indoors because it's not waterproof. So I'm just going to multiply fractions, because multiplying fractions are easy. I'm just going to multiply the numerators and multiply the denominators. So the probability of her taking 2 blues is 15/72, and if I'm feeling really fancy, I know that 15 and 72 have a common factor of 3, so it would also be 5/24. That's part B. Part C says work out the probability that Tina takes 1 of each colour. I'm going to come back to my tree diagram. Now 1 of each colour, well, there's actually 2 ways she could take 1 of each colour, because it doesn't specify the order. It doesn't say it has to be in a certain order. She could take red and then blue, or she could take blue and then red. I'm just going to box off this star because I've done that one now. I can ignore that now. Okay, so I'm interested in either red-blue or blue-red. Both of those mean she takes 1 colour. So I'm going to do them independently. So let's say C, and we want the probability, this is just a bit of fancy notation, don't worry too much if you know it, of red then blue. Well, the probability of red then blue, I'm going to do it just like how I did my blue. Probability of red here is 5/8 and blue here is 5/9. So it's going to be 5/8 times 5/9, which is going to be 25/72. Okay, and then the probability of blue then red, I'm going to do the same way. If I come back to my tree, blue then red is 3/8 times 4/9. So I'm going to do 3/8 times 4/9, and that's going to be 12/72. I could simplify that, but I'm not going to simplify it at this moment in time, because I want either this thing to happen or this thing to happen. The question asked me that she takes one of each colour. It doesn't specify the order. She could take one of each colour by doing this thing, or she could take one of each colour by doing this thing. So what I'm going to do, if I want this or this, I'm going to add them together. Remember, when I wanted this and this, I had to multiply them together. But if I want this or this, I'm going to add them together. So the probability of red then blue, make that capital, or blue then red, which is the same thing as saying the probability of getting one of each colour, is, well, red then blue we know is 25/72. Blue then red is 12/72. Apologies for the shadow, I will take a picture of this nice and clearly at the end so you can see it nice and clearly, which is going to be 37/72. So that's the probability of one each colour. I had to do the two different ways of doing it and then added it together. Any questions, remember, make sure you email me and I will take a nice clear picture of this so you can see it all in one go. Remember, obviously you can pause the video as well.